Okay, in this video, what I want to do is start looking at how to test effects with ZIO Test. So as a note in my comments here, first thing I want to do is show how to use assertZIO to test effects. And then this second note is a little misleading and maybe a little out of date. I want to show how to test ZIO effects with for yield. And the reality is I'm going to show how to test it with for yield in this area right here. And then I want to show better ways to test that down here with assertZIO. So that second line is a little misleading. It should say, I want to show how to test it with for yield, and then show a better way to do that. So as usual, we create an object that extends ZIO spec default. Here I'm creating the spec as a suite as usual, and then I have two different suites that I'm going to be testing inside of here. So we want to look at the first one here first. This one is called Basic Effects Suite. So let's take a look at this first one, and all I'm doing is creating a simple effect right here. So I'm saying I want to succeed with that value 42. So the way you use assertZIO is that you have your effect in this first parameter group right here, and then you have your assertion tests over here in the second parameter group right there. So to be clear with what's going on here, I could say that I have an effect equal to this, like that, and then put that in there like that. And then I could add this type right here. So we're going to say that that is a ZIO of any, nothing, and an int. I showed how to think about and write these types before, so I'm just going to skip over there. Let me save that, and then we want to run Scala CLI test. And what did I call this? ZIO Test 104 something else. And then I have intentional errors down here. So let me come back and change that real quick. Don't want those errors messing up what we're trying to do here. Okay, so now we see that everything passes. So the first thing I'm showing here is that when you have any type of effect, and of course this is just a very simple effect right here, this is how you test it with assertZIO. Put your effect in the first parameter group here, and put your assertions in the second parameter group like that. The second test here is very similar. I'm just using a string instead of an int, and then saying contain string ZIO right there. Let's see what I'm doing in this third one here. So this is kind of an interesting one here. I'm saying ZIO.fail and return the string error as the failure message right there. And then I call flip on that. And this can be a really nice one as a note right here. Is what you can do with flip is you could take a failed effect and then you can flip it to transform that failure into a success for our purposes of testing. So in our particular case, from here to here, we're saying I want to fail with the string error message. But then we flip that around into a success, and what that does is it lets me test that the string is equal to error right there in that second parameter group. So that's kind of a nice use of flip right there, I think. And if we come over here to the ZIO documentation, you can see in the documentation here, it says it returns an effect that swaps the error in success cases. And you see that in type signature right here. Instead of being R, E, and A as usual, now it's R, A, and E. So they flipped these two parameters right there. They note that this lets you use all the methods on the error channel, possibly before flipping back. And I'll try to cover this more in future videos. But for our purposes right here, I am just taking this ZIO effect right here and then flipping it so that I can get that error string right there as a success value. So that's something really nice for testing right there. So then in the third test here, I've already shown how to use label, and the only difference now is that I'm adding it to assertZIO instead of adding it to assert or assert true. And I think what I was doing, and I'm sorry I forgot what I had in there earlier. Did I just have 43 here? So if I run that, we can see the first part here is the path to our test, which is always really nice. That's the main suite, the suite that we're currently in. And then this part from here to here is the label on our current test right there. And then we get the results here. 42 is not equal to 43. My note right here is I expected the value to be 43, and then so on. So Again, I've covered label before, so I'm not going to get into that too much. I just wanted to show that you can use it there. Now, if we scroll down here, we can look at the second part of this video. So what I'm doing here is I'm creating a more complicated example. So let's move that out of the way there so we don't have to see that yet. So I just want to focus on this code. So what I'm doing, and I think I've shown this in previous videos, is I create a trait named mathService. It has two abstract functions. You can tell they're abstract because there's no equal to ... over there. I'm just defining the types, and I'm saying add takes two integers and it returns a UIO of int, and divide takes two integers and returns an IO of string and int right there. So I'm using this trait here. Really, mathService is an interface. And then what I do here, I note that this is an implementation of the service, or the implementation of this interface right here. So I have mathService equals a new mathService, and then I implement that first function like that. So this is ZIO.succeed on A and B. And then divide is, of course, a little bit more complicated. So we have if B equals 0, then I want a ZIO fail right there. Otherwise, we'll do a ZIO.succeed and do that division right there. Then I have this note here that this is not the preferred way to write these tests, but I do want to show this anyway. So now I'm creating a new test suite right here, and I have the two tests that are shown here and here. What I'm doing inside this first test here is I have this for yield expression. So I have mathService.add, and if we look at that function up here, you see that it's returning a ZIO type. So this is returning an effect, but when I get the result over here, and then when I work with it down here, I'm just working with that int type as shown right there. So I can go back and say, well, I can just use assert true here. So instead of using assertZIO like I was in these previous examples, when you use a for expression like this, you can go back and use assert true right here. So I do the same thing for mathService.add and for divide right here, is I use assert true here and I use it here inside of the for expression. But again, even though this works, this is not necessarily the preferred way to do things. So let me comment that out. And now we can look at this other code here. So I have a totally different object here, mathService spec. And in fact, because that is different, I should scoot all that over like that. And let's go back to that. So again, ZIO spec default, here's spec. This is our new suite, and I have 3 tests in here. So what's going on here is up here, I had those 4 expressions, and what I'm doing here is I'm getting rid of those 4 expressions. So the way you do that with assertZIO, as I note right here, assertZIO takes an effect as the first argument, and then it takes the assertion as the second argument. So that's what's going on right there, is that instead of using a for expression, assertZIO can take this first parameter here as an effect. And this is really interesting because if you recall, an effect is just a blueprint. It's not something that's actually running. So inside of assertZIO, there's some smarts to say, you know what, go ahead and run this effect right here, evaluate that effect, and when you're finished evaluating it, then come over here and do this comparison using this assertion right here. So this part here is a real key, maybe from here to here, is that assertZIO is able to take your effect inside of here, evaluate it, run it, and then perform this comparison. And that would be much more difficult if you're using another library like, I don't know, Scala Test, MUnit, or JUnit. So I just showed how to use assertZIO here with the add function. Here I show how to use it with the divide function when we get the correct answer that we want. And then what am I doing down here? I am showing, for cases where you expect a failure, you can use exit to get the exit value of the effect. So what I'm doing here is I'm dividing 6 by 0 right there. Of course, that's going to fail, and then I call .exit on that. And that is going to get me the exit value of the effect. So if we go back and look at that divide function right here, we can see it's division by 0 right there, and it should be division by 0 right there. It is indeed. So let's see what I've done here. So let's see if I made any mistakes over here in my formatting. Okay, just to simplify my life, I commented everything out about this, and then I moved the math service code inside of this ZIO spec default object. And then we have the spec here, just like we had before. So I was just running into some problems with the previous code, so for me it was just easier to comment all that out. And now we can just go ahead and run these tests right here. And I should come back here and note one thing that I forgot to mention here is that this is a really nice way that we could test failure. So here we're asserting this effect and we're expecting failure. So we call .exit and that gets us that exit value. And now we use the fails assertion function right here and saying that this is what we're expecting. So even though our divide function fails, it fails as we expected it to, then we could perform the assertion right here. And then you could see this ends up as a nice positive test right up there. So I didn't emphasize that enough earlier that when you're testing failure, ZIO Test has some nice things like this that you can use, and then the flip method that I showed earlier.